I know that people need to go, and so if you feel that you need to leave, please do so. You can stay for a couple of minutes for questions, and then you can catch up with Amy and ask further questions.
Okay.
And you have to be someplace at 1:15.
1:15 or 1:30?
I think it's 1:15. For lunch?
For lunch, 1:15.
1:15. Yeah. Lunch is ready.
Charlotte.
One question, and some of the earlier part of your talk, you were referring to the basal ganglia and showing a negative finding. And we know that different parts of the basal ganglia have different functions. So
Yeah.
I'm guessing already that you're actually looking at different subdomains. of the
Yeah,
ganglia.
yeah. So for filtering in particular, the previous work has focused for good reason on the globus pallidus, right, because of its direct relationship with the prefrontal cortex, and so that's sort of where we focused things initially. Strangely, in the functional imaging data, we were seeing caudate, which are more important for sort of learning, and so we looked at both, and we looked at them separately and grouped them together. And the reason I presented you data where it was grouped together was A, I didn't have time, but B, it's the same story. But you're right, like a negative finding doesn't mean that it's not there. It means that maybe we did something wrong in terms of designing the experiment, and an fMRI means we didn't necessarily do the right analysis. And so what I was showing you was just the first pass where we looked at native space segmentations using FreeSurfer, but those are big-ish in terms of ROI land, and so we might actually be missing quite a bit in terms of differences in averaging those out with that analysis. So yeah, we're looking at that. I don't know that that's the story yet, but the data are more complicated, at least with this first pass, than I would like, and I wanted to sort of package a pretty story for you guys. So that's the story so far. Yeah.
In the last study you presented in detail, you had the different SES groups and the NBAC and the selectivity in the brain, and then the scores on the Massachusetts test. And I'm just wondering about what kinds of inferences you really want to make from that kind of data. So it's
Yeah.
essentially correlational. And
Yes, the
if
regression.
you wanted to make a strong claim, you'd say the environment, which is how you partitioned your subjects, then determined how selective they were in their ability to use their brain regions to perform different levels of difficulty in the NBAC task, and then that also related to their ability to succeed on these aptitude tasks. An alternative view would be, good things go together.
Yeah.
And so I'm just wondering where you sit on that.
So, I mean, I think based on the statistics used, we say good things go together, right? That's what these data show. I think it's important, though, because we're talking about particular kinds of good things. And so this is, I think, the first study to actually look at individual differences in functional recruitment and relate them to things like achievement. And what we're seeing is that those who are achieving more have are better at titrating their prefrontal cortex.
So if you pulled out SES, would you still find a better predictor of performance by the titrating of the brain?
Yeah,
if you pulled it out?
And what I showed you was actually looking at that separately in each of the different groups. But then sadly we don't have a nice continuous measure of SES on this sample. Future work, we're going to have that. But it would be important to sort of do a regression where we're controlling for that, not just as like a binary, but with the actual values themselves. But yeah, no, I think this is just a first step toward trying to characterize the importance of a particular neural recruitment profile for something like achievement. But this is absolutely not causal. It is related and different in each of the different populations that I'm looking at, right, which differ by environment. But careful longitudinal work is really important in understanding what these are, and that's not what this is. Yeah.
Well, I had a question about the results of experiment 3, which said that adults trying to learn languages more was actually impeded their learning. And it's more to do, like my question is less regarding neuroscience and more regarding applicability of that data. So does that basically mean that you shouldn't do your homework in language courses?
Absolutely.
No.
Like I'm just kind of curious, like how those results would be applied in actual language learning.
Yeah. No, I get that. So when this study came out, that's the question reporters asked over and over. So, no. It turns out you're an adult and you have these memory systems, and it might actually be that the best way to learn a language would be trying. And in fact, what we're noticing in terms of individual differences is the better you are at trying, the better you tend to be sort of naturalistically at learning languages. And it's not and my study doesn't show that it's language across the board that trying hurts, right? It's just this particular aspect of language that adults are bad at, which is morphosyntax. And so I guess my real advice would be to try to learn it. You're an adult, that's what you need to do. But in trying to learn it, you should have like motivated hypotheses about what the structure is, and you should actually have a lot of meta-linguistic knowledge about what you're looking for so that you can actually aim those resources appropriately, which wasn't necessarily the case in my study, and that's actually why I think trying harmed those learners. And then once you get to a certain level, I don't know what that level is, don't cry as much. You know, play with the language more and let your sort of procedural resources take over to the extent that they can. I'm doing a lot of really fun experiments that may or may not work out, but that are like super fun. Trying to see if we can get adults to learn better by taking certain mnemonic resources offline. So the easiest way to do that is like a tone counting study where during the learning you have this alternate task, and does that help? There's also fun experiments where we can use transcranial magnetic stimulation to sort of create a temporary lesion in the prefrontal cortex. And also sleep deprivation selectively taxes various of our neural systems, and especially the executive ones. And so those are like some fun studies I'm doing. I don't know if they'll work out because I think it actually really matters a lot at what point in the learning you are. And so the stuff I showed you is like an artificial language that's auditory, doesn't mean anything, but I have other work where we actually develop these miniature artificial languages. It's based on my former advisor, Carl Hetzenkamp's work, where you actually learn a really small experimentally controlled language in the laboratory, and with that we actually can sort of do interference at different time points after like a certain amount of information is learned. And so, no, you have to try, you're an adult, like, you're not gonna, and Pat Cool has lots of interesting studies showing that even if it's like, if you just listen to language in the background and don't try it, don't learn it, right? You have to, there's a social component and all this other stuff that matters quite a lot. It's pretty complicated.
I think that probably should be the last word, unless people want to follow you out as you're going to lunch with the graduate students. Thank you
Okay,
very
thank you.
much.